Sorry, I'm just trying to get the recording up and running here. Okay, there we go. Or I mean my screen share had a little issue there. Okay, cool. So I want to do a bit of an overview. We'll do a bit of an overview today and just reflect a little bit on while loops and loops in general. And the bulk of today's discussion will be, today's topics will be on strings. Strings are a data type that I know we've gone over a little bit, but we're going to dive a little deeper into those as well today. They're sort of a complicated type, data type disguised as a simple data type. So don't worry, they're not too hard to use or anything, but there's some nuances there that are worth discovering. Okay, cool. So we've got a while loop breakout here that we're going to do after a little bit of a description here. So let's do our overview real quick. So this is the overview of Python. Let's just call it Python. Now this is not a, to be clear, I know that I say this every time, this is not a comprehensive overview. This is not every feature there is, or paradigm or topic that there is to cover in programming or in Python. It is a way of approaching learning Python from being a beginner to being competent and having a complete set of tools, a complete but minimal understanding of the language to get you off the ground and running. So what we want for that is we want to understand the types, the data types that are built into Python. We want to understand some abstractions. We want to know about control flow and iteration, and that's it. But of course, each of these can get quite a bit deeper than just this. But quickly, I'll just touch on the data types that we've gone over: int, float, bool, none, string, list. I always put the space here for lists. Lists are a mutable type, so I like to keep my mutable types kind of categorized separately. Lists, we have sets and dictionaries, which are a couple types that we're going to get to in a later lesson. But we also have tuples, which we haven't gotten to here yet, but we'll get to those probably in the same lesson. These are the ones that we've covered and kind of worked with more regularly, though. So obviously ints and floats are our number types. We can do math with those mathematical operations. We can also use integers to subscript into a location and index into a string or a list. We didn't so much go over indexing and strings. We'll probably touch on that today. We talked about indexing, or more properly known as subscripting. With lists, if you understand how those rules work with lists, with elements in lists, the same applies for characters in strings. So we can use an index in a string to get a specific character. We talked about lists. We talked about mutability, what it means to have a mutable method. Let's do I'll do it just occurred to me, we'll do a little breakout on this. I'll put just a minute or two on the clock. In your own words, let's kind of reflect on lists. I want to get your your best reflection on, in your own words, what is mutability versus what is immutability. I'll just do this. I'll pop this in Slack. I want you all to get thinking about this one. Okay, there we go. Mutability versus immutability in your own words. Okay, cool. So I'm seeing a lot of really great descriptions here. It seems like people have this clear idea, we can, maybe just based on the words, mutable versus immutable. Mutable is obviously related to mutation. It's talking about the ability for a data type to change. And one thing in your understanding that I want to capture, and I suspect most of you do understand this, right? If I have an immutable type, right? So, well, we're going to talk about strings later today. Let's call this let's just call it text. Okay, so if I have an immutable type, a string is an immutable type. Is there anybody, so if I do this, right, I've got text equal to hello, and then I print text and we've got hello, and text equal to world, and now we've got hello world, right? So text is now equal to hello world, right? If there's anybody that is looking at this and saying, wait, this looks like mutability, feel free to ask any questions about this right now. This is a good opportunity to suss this out. It's one of those things where it's a kind of a subtle detail, but it's something that if you don't understand can kind of come around to bite you later. So here we have an example of a string, and I'm telling you that a string is immutable. And I'm assigning it to this variable, this identifier or text. So what I'm doing here is I'm getting a different string. I'm concatenating, I'll just type this out in the long form here. Text plus world, right? So hello plus world, text equals text plus world. So this gives me a different string, and I see somebody mentioning this. The ID will change. Yeah, so this is going to be a different string in memory. I'm not taking this object and adding world to it. I'm saying, give me a different string with that string plus this other string concatenated against it, that produces a different object in memory, and then save that object happens to be saving that object under the same name, right? So this is important to remember, because this is a way that we can recuperate a behavior that is similar to mutability without having a mutable object. If you kind of think through these patterns, there are certain times where mutable systems, I mean, mutability is the addition of a powerful feature, and immutability is the absence of that ability, that feature. But you can see with this, we can still basically, or in a lot of circumstances, we can emulate behavior that would otherwise be mutable. There are times when the power of mutability really makes sense. There's times when it can speed up your code, or not. You can avoid unnecessary duplication with mutability, but a lot of times it's fine to just take a tiny little hit and make a little bit of duplication for the sake of having data that is more predictable. That is generally kind of quote unquote safer. But okay, great. Y'all did really good. Okay, abstractions, we'll just say variables. Functions, control flow, if, elif, else. I'm not going to go into too much depth with those. I think y'all get at least what functions and variables are for, and what control flow is for. Let's touch on iteration though. So we have for loops and while loops. For loops and while loops. So we'll treat this one as a little breakout too. Let's see. Okay, next breakout question is, let's do, when should I use a for loop versus a while loop? Oops. Oops. There we go. A little more than half a minute left. Go ahead and get in an answer if you'd like. I'm just going to kind of read through some of these. So for loops are for known quantities, for iterating through known quantities, whereas while loops are for while you're waiting for a condition. Use a for loop when you know how many iterations you need. A while loop when the number of iterations is unknown. While you don't know what the ending thing will be. Yep. For you do know what the ending thing will be. Well said. Nice and succinct. Captures the idea well. While loop when you don't know how many iterations it'll take. Yep, cool. Yep, I won't read all of them, but yeah, it looks like I'm seeing pretty good answers on this. So I'll give you I'll say it in my own words. I would say, so with for loops, when you can determine the number of iterations necessary to solve the problem before the first iteration takes place, then you can use a for loop. So I state it that way because it's very broad, but it might even kind of seem more complicated than it actually is. When I say the number of iterations can be determined, a lot of times it's like you don't have to determine it. It's just like you already have a list or a number that, an in that describes how many iterations that you'll need to perform. So a lot of times that information is just given to you, or you just you're writing that loop inside of a function and you're taking that in as a parameter, or you're getting a length of a list or something, right? So a lot of times that information is just handed to you and it's very obvious. Sometimes there might be an extra step or two that you might have to take to determine the correct number of iterations necessary in order to complete a looping process. In the cases where you can determine the number of iterations necessary to solve the problem before the first loop starts, before the first iteration, you can use a for loop. In cases where we can't determine the number of iterations necessary to solve the problem, we have to use a while loop. So for that reason, while loops we consider to be more powerful than for loops. So real quick, I'll just get a couple answers. Go put it in Slack. Why would I, since while loops are more powerful, why would I want to use a for loop? I'll just wait for a couple answers. I won't put a timer on this. I'll just get 3 or 4 in there. Same reason you might use a screwdriver over a drill. It's less dangerous. Yeah, actually, it's a really good analogy. Yeah, a drill is more powerful. Technically, we could say like a drill can technically do everything that a screwdriver can do, and in some cases it can do some things better, or it can do some things it's a more powerful tool. It maybe can do some things a screwdriver can't do, but screwdrivers are still pretty useful. If you have a drill, it's probably still a pretty good idea to have a screwdriver too. While loop needs a breaking condition, otherwise if not coded properly it could run forever. Yep. Tell you a quick little interesting story. When I very first was learning to code, I took a class. It was actually a beginning Python class, and the way they oriented the material, they didn't teach us functions at all until like way late in the class. I tried to teach them really early, and they didn't teach us for loops. So like basically we had some basic data types, numbers, booleans, strings, lists, none. We had while loops and we had conditions, and that was all they taught us. And like the whole class was basically oriented around using those things. And I was really, really new to programming, and I didn't know, when I would run my code, I didn't know how to stop it. I didn't know like how to stop code, a program that was running in my terminal. So I just was constantly at this little netbook that was just constantly overheating because I had one infinite while loop after another. My computer was just like I could have cooked an egg on the keyboard. It was always so hot. Yeah, so they can be nasty. So that's why I teach for loops first. I'm like, this, like you do most of your work with for loops anyways, and it's the same basic idea. They're just so much easier to use, and it's nice to like have a tool that gives you the idea and is kind of easier to use while you're learning how to stop programs running in your terminal, for example. So, all right, yeah, it looks like we got a lot of good answers here. So. While is really powerful, sometimes we need to use it in certain cases where a for won't do, but wherever we can get away with using a for loop, it's a tool that is simpler to use, and that's not to downplay its utility. That simplicity also kind of comes with some elegance, right? A for loop is a bit more of an elegant solution. It's a bit more makes usually for a few less lines of code. Often that code is easier to read. You kind of have a lot of important information on one line. It's laid out in a very kind of clear way in the loop head, and it just takes care of a few things regarding looping for us. It makes a few useful assumptions that in most cases we want to make anyways, and makes most of the looping tasks that we need to do, or many looping tasks that we need to do, just kind of simple and easy and straightforward. So cool. All right. Let's get into things. Let's do this while loop breakout. Let's see if I can just do this. Sorry, let me just format this really quick in my editor. Okay. There we go. Okay. These go like that. All right. There we go. There's the breakout. We'll have 5 minutes on the clock for this. We got a question in chat. Says, so you can't get a stack overflow with an infinite while loop, but you can with recursion. Is that correct? Yes, that's correct. Recursive functions, every time they call themselves, add another function to something called the stack, and it's called a stack frame. So every function call corresponds to one stack frame. So when the stack gets too big, it quote overflows. Some of you may have heard of the site Stack Overflow. It's a great place to ask programming questions in Python or any other language. There's a lot of good places, and that's a famous one and a good one. Something that you'll probably make use of at some point, frequently, or at least sometimes in your career. But that's where that phrase comes from, is from that recursion error. Whereas each iteration of a while loop does not add another stack frame, so it just repeats a process sort of arbitrarily. Also, that's a good question. Quick reminder to folks, as you're working through this, presumably you're working in either Replit or perhaps you have VS Code set up by now, or Jupyter, or whatever your environment is that you have working and are comfortable with. I encourage you to write a test at some point. Usually first thing is what I recommend. And run your code while you're working on it if you need to. So just wanted to mention that as a side note. It is not cheating to run your code while you're solving the problem. So it's just regular programming. So. All right, cool. That's 5 minutes. Looks like we've only got, I see one answer. Carl the divisor finder. That's how we're all gonna be naming our functions. Just literally give them a human name. Steve. I want to wait for a few more answers to come in. I'm going to extend our time just by, we'll do another minute and just see where we're at. So if you're not quite ready, don't worry, go ahead and keep working through. Might do another minute or two. I want to give people a fair shake at this one. I want to wait till I get 3 or 4 more answers at least before we move on. So let's get 2 more answers in. Okay, we'll leave it there. Let's kind of look at a solution here. If you're working on something, you can feel free to like put on your finishing touches and just get in whatever you've got at the moment. It's okay if it's not complete. It's good, it's good to post in your solution. Maybe you're thinking about something in a way that, somebody could benefit from. So, all right, so the goal here is write a function that computes and returns a list of all of the divisors of some positive number. Use a while loop. Things to think about. How do you determine if a single number is a divisor of another? What about the stopping condition? Rewrite this as a for loop. So I'm gonna cheat and I'm gonna write it as a for loop first because it's pretty easy to turn a for loop into a while loop. It's not that hard to do a while loop into a for loop, but for loops are easier to write. We'll start there and then we'll rewrite it as a while loop. So I'm going to do a quick an IPO, input, process, output. And input, process, output, that's going to be our inputs is going to be n, which is an integer. I'll say a positive integer. Yeah. I'm going to do output is going to be a list of integers, a list of integers, representing all the divisors of n. Cool. And then process, I'm just like, I don't want to really type that out because I'm just going to be describing the algorithm that I'm about to implement, and my notes would probably just end up being Python anyway, so I'm just going to write Python. Okay, so I just stubbed this out. I will pop this in Slack, just if you want. This is just the start of the function that I like to start with. I just have a test down here. I want to just test. I didn't want to write a bunch of tests. It's not that hard to write a for loop and just test numbers from 0 to 19 in range 20. So this isn't a huge amount of output. It's just 20 lines. It'll just give me a little bit, it'll give me a sense of if the function is working correctly. These are small enough numbers and there's few enough of them that I can just look through and make sure that I'm getting the results that I expect. So, and then you can see our output. Why don't I run this just to prove what we're going to get? Right now, our function isn't returning anything, so it's returning none. And then we just have I followed by the result of the function. Okay, so that's our output. That's what we're seeing right now. So my whole MO is around doing what is obvious and easy first. I know I want to return a list, so let's do that. Let's make a list. List equals empty list and return that. That's one small step closer to our goal here. And then we're also going to need to iterate through all the numbers that are potential divisors of n. So that's going to be for I in range. We can't start at 0. If I started at 0, why don't I do this? If I did for I in range n, I could do n plus 1, because n technically could be a divisor. There are different ways of doing divisors. There's like proper divisors, which I think doesn't include 1. 1 is not considered a proper divisor, but n is, which is, I find that weird. And then there are other like divisor sets that include 1 but not n, and n but not 1, which is proper divisors, and then others that don't include either, and others that include both. I'm going to include both just because this doesn't specify which, so it's up to me. So I'll include 1 and n itself. So if I did this is going to cause me a problem, because if I try to find out if I is a divisor of n, I can say if n mod I equals 0, right? N mod I equals 0. This is a pretty common line, this line or a line like it. Obviously you might have different variable names, but you want to see if something is divisible by something else. It's a mod b equals 0, or n mod I in this case equals 0 will tell you if I is a divisor of n, because if it goes into n without having an even number of times, it will have a remainder of 0, and the modulo operator gives us the remainder back. So if n mod I equals 0, we will list.append I. So can anybody see the problem I'm going to encounter with this? Wants to tell me what this is going to do. And this is just kind of a fun exercise. Feel free to answer it by writing this code in your editor and running it and seeing what's going to happen. Yeah, 0 division error. Somebody said 0 division error, exactly. So that's because range, and I know I kind of alluded to this, but range starts at 0 up to n. This is n plus 1, right? So I don't want to start at 0 because I'll get this 0 division error, because we can't divide a number by 0. How many times because that's like asking, how many times does 0 go into n? I mean, is the answer infinity? I mean, maybe, but there's debate on this. What is it's either infinity or it's undefined or something. So Python's opinion on this is to not have an opinion on it, to throw an error. So, which is the right thing to do. So we can't do that. We want to start a range at 1. So this will do it. This will solve the problem. Very simple solution for this. We could optimize this a little bit. I'm not going to worry about it though. We're a little short on time. I'm just going to turn this into a while loop solution. So I have this range. I'll just comment this out, and this range is giving me I. The first value that I starts out as 1, and for now I'm just going to do while true. We'll just a while true line is just loop forever until you tell it to stop. Until you reach a condition and you break. So I'll start my loop like this. I is started at 1, and I always like to increment my controller. I is going to be my controller essentially. I always like to increment my controller right at the top of the loop. That way I always know where it is. If you get 10 or 15 lines or 30 lines, but even 5 to 10 or 15, you can start it's enough that you can, if you don't have at least some way of laying things out consistently, things can start feeling like they're getting lost, and you can get into a situation where it feels like you've got things everywhere, right? So as a rule of thumb that I personally like to follow, I like to modify my controller as close to the top of the loop as I can. Sometimes you can't get away with that. Sometimes it's got to be at the bottom. Sometimes it's got to be somewhere in the middle. But more or less, if it makes sense, I'll try to increment that as close to the top just so I know where it is. In a small solution like this, it literally doesn't really matter, but for the sake of consistency and like my own edification and coding style, that's what I like to do. And that's the reason I like to do it. But you can do what you want. It occurs to me that I'm gonna exit this when I is greater than or equal to n. The reason really, I want to exit this loop when I is equal to n. In a while loop, we always do this thing where instead of checking if a number is equal to another number, we check if it's either greater than or equal or less than or equal. Because if something weird or unforeseen were to happen and the value of I somehow skipped n, which I'm incrementing it by 1, so it can't, it'll reach it eventually. But, just in case I change this code or something weird or unforeseen happens and I skip the value n for some unknown reason, that condition will be true for all values greater than n. So it's false in a range and true in a range rather than false in a range, true at a single point, like equality, right? If I check if I is equal to n, that condition is true at a single point. There's only one scenario where that condition is true. But if I include greater than or less than, there are 2 infinities that represent truthful states and falsy states for that expression. So for the sake of safety, we always do that range thing. Okay, so I'm going to need to exit so I'll say while I is less than or equal to n. That's my exit condition. Since I'm going to increment right away, I actually do want to start I at 0, and then the first used value of I in the loop is going to be 1 because I'm incrementing it right away. Okay, so if in mod I equals 0, we will list append I. Yeah. There you go. So that'll do it. I'm just curious. It does give me a slightly different result with 0, but that's okay. Doesn't really matter. There's kind of a loose constraints on the definition of this function. So to be clear, both of these could be optimized to a pretty great extent. We could check less numbers in the range. We could do this something similar here. But both of these algorithms, they're simple, they're straightforward, and they'll work. Okay. My, how the time just flies. There's some examples. You can look through the slides if you want to look through that. Something I want to touch on regarding while loops. We're going to save this breakout, I think, for next time. I'm going to touch on this, and then we're going to move on to strings. Sometimes you'll hear the term open-ended problems in relation to while loops. You might have an intuitive sense of what that means, and it might kind of make sense. What we mean by this is an open-ended problem is a problem that we don't have a clear, defined, or yet discovered end to. It's basically a different way of saying when you don't know the number of iterations needed to solve a problem. That's called an one word for that is an open-ended problem or term. Using a while loop to make a menu, like a little menu that your user could use. Let's do this. Oops. Let's do that. Okay. So this is a literal menu for ordering from a restaurant. Just if your restaurant let you order from the terminal. I don't think I don't actually remember this. I believe in the beginning of class, we talked about the input function. If memory serves, I kind of went over it really quickly, and then I said, I don't want you, this can be useful at times, but I don't want you to focus too heavily on it because if you use input a bunch, it can feel like it slows your program down, and it can make it feel like hard to test, hard to run and mess around with. So in terms of like keeping things easy for development, it can seem like, oh, this is going to make my life easier, and then it can just kind of make it harder in a weird way. So there are easier things to do when you're testing your code than using input. However, input can be really, really useful inside of a while loop, right? We can say, let's just have a while true. So this just says loop forever. And we can use input to prompt the user. And you can see I ran my code and I get prompt the user, and I put in my data. Right, so this is running forever. This is an infinite loop, but it pauses. It's not gonna like blow up my CPU. It's not gonna overheat. I'm not gonna fry eggs on my keyboard. Not that you should do that anyways. You should never do that. But it's going to pause between each iteration, right? So it's not just whirring away forever in the background. It's, this loop has done 1, 2, 3, 4, 5 iterations. That's it. So if you have let's say you make a little terminal application, you could do this with a you can make like a text adventure game, and you each iteration of the loop, you prompt your user for input, you validate that input. Once you've determined that that input is valid, if it's not valid, you say invalid input, and you ask the user for new input or do something else. And if it is valid, then you perform the action associated with that valid input, and update the state according to whatever that action is. You update the state of the program, present the user with new information, and ask them for another input. So it's this kind of cycle: input, validation, perform the action, update the program state, present the user with information, and then ask for input again. And that's a cycle of a lot of programs that are taking user input, right? This isn't going to make a graphical application with a while loop and an input function, but it'll make a terminal application, which is still pretty cool. And you can do some really cool things with simple terminal applications. That might not be like the flashy thing that you want to show your friends, but it's you can make a lot of really cool, useful stuff for yourself, and maybe your nerdy friends will be pretty impressed. So, yeah, you may have heard of like a program having a main loop. Generally, in modern kind of formal design, when we're writing software or writing programs like that, that main loop is generally abstracted away from us in some way. It's hidden in a library somewhere, and we have a nice modern, kind of custom tailored interface to that library that's going to kind of use that main loop for us. So we don't, in Python, the paradigm isn't as much to write a main loop directly, but sometimes you can. I mean, this is how you could do it. So let's just make something up really quick. Let's say I was going to go with a different example than the restaurant menu, but I'm literally going to go with the restaurant menu. So let's say select from the list. So here's the menu string. We'll say menu string, and then we're going to print menu string like this. So it says select from this list, and then we'll say please make a selection 1 through 4, and we want to capture this as imp. We'll call it imp for input. So this is what the user is inputting. And then really quickly, I'm going to say, I'm going to do this Q to quit. First of all, it's always nice to have a quit so you can actually quit your program. So I'll say if imp equals Q, and let's do imp.lower. Oh, come on. If imp.lower equals Q, break. Otherwise, we'll cast imp equals int imp. We'll just assume we got valid input. We won't do an input validation step here. We'll just assume we can cast it to an int, and it's going to be okay. We'll cast it to an int, and then I'll say if I don't want to make it too complicated. We'll just list.append imp. I'll actually cast it to an int right there. That way I don't have to do this weird variable reassignment thing right here. Okay. And let's make a list, lst. This is an accumulator pattern. And then once we quit, we're going to print list, something like that. So this is basically just a reduced version of this. Just a simplified variation of that. All right, so this is just a good example of how you can use input with how you can use input with a while loop, and they kind of work really well synergistically together. Usually you don't want to write an infinite while loop, and sometimes using input really isn't that helpful, but a lot of times it really makes sense to put them together because input kind of slows down the execution of your code, which is useful for an infinite while loop. Kind of justifies doing that. So I'll hit Q there, and then I'll get my list printed, and that's a list of all the numbers of my orders. So, okay. Now go write a text adventure game. Cool, that puts us right about at halftime. Let's take a short break. Let's reconvene at 5 after the hour. You got somebody asking me if I can scroll up for a sec. Yeah, I will do that. I'm just gonna make a quick update to something. Oops. And I will do that in 1 second. I can send, I'm just gonna send this example in if that would be helpful. Presumably, I'm presuming that's where you wanted me to scroll up to. Cool, you're welcome. All right. Let's get going again. Oops, what am I doing? Okay. Let's transition to strings. We'll talk about strings. Declaring strings, string methods, functions with strings. So the string data type, so strings are a collection type. They are immutable. They're a collection, you think about, we talked about lists. Lists are a collection of anything. We can have a list of numbers or a list of strings or a list of lists of numbers if we wanted to. We can have a list, or excuse me, so a string can contain any arbitrary type, whereas a list, or I just said that backwards. A list can contain any arbitrary type, whereas a string can only contain characters, right? And a single character is considered a string. A string with no characters in it is called an empty string. Surprise, surprise, but it is a valid string. An empty string is a valid string. That's important to know because say you start a string accumulator, you want to start it as empty string, and that has to be okay. Okay, so we can declare strings with single tick or double tick quotes in groups of 1 or 3 at the beginning or end. So for those of you who were in study hall today, I talked about comments briefly at the end. We talked about multi-line comments. You may remember that a multi-line comment is apparently exactly the same as a multi-line string because we actually use multi-line strings as comments and as multi-line comments in Python. So if I want my string to exist across multiple lines, I can say, let's do this. I'll just call this text equals this, and then I'll say print text, hello world. So I think we have pretty well established the basics in that we can surround a string with single tick quotes or double tick quotes. I prefer to use double tick quotes. The Pythonic thing to do is to use single tick quotes. The reason I prefer to use double tick quotes is I find myself using the apostrophe character while I'm typing. Just regular, but if I'm making a string, it's not uncommon that I'll put a word with an apostrophe in there. The apostrophe character is the single tick quote character. It's the same character, so that can cause a conflict. If I say text equals that, yeah, oops, we'll do that. It's got that apostrophe in there, versus if I had this with single tick quotes. I don't know if you can see it, the syntax highlighting, it's a little bit subtle, but because the string is yellow and then this is white again, and this is actually going to give me invalid syntax. So you can see Python thought I wanted to end the string right there. And there's no way around that other than to put a backslash in front of that character and say, no, that's not an end of the string. It's literally an apostrophe character. So that makes my code look just slightly weird. It's not that big of a deal, but I don't know. Kind of like that better. So it's my preference. The Pythonic thing to do is this, though. If you want to code in an ultimately Pythonic way, this is what you're supposed to do. If you want to adhere to PEP 8 strictly on that. To be clear, it's fine to diverge and develop your own style and diverge from PEP 8. I have a different opinion than the people who developed Python and PEP 8 on this. It's fine to do that. It's canonically considered fine and okay to do that. Nobody's going to shame you for doing that. Just make a decision about what you want to do and do it that way every time, more or less, you know. And if you diverge from that, let there be only diverge from your usual way of doing things for a good reason, right? So yeah, that's my only thing. Okay, so that's strings. That's how we can declare them. Single line string or a multi-line string, same diff. Basic string operations. So we can do something called concatenation, which I showed before in that example when I gave text. We were talking about immutability. So we'll say text, hello, text, oops. And then let's print text plus world. And let's concatenate a space in there. Okay, of course I could put the space in there, but just showing a different way to do it. So hello plus world is hello world, right? So when we use the plus operator to add two things together, we call that concatenation. And technically in this context, it's the concatenation operator, although, you know. We can also multiply a string by a number, which is a little weird. Let's multiply it by 3. Hello, hello, hello. Hello, hello, hello. Just like that. And then, of course, none of these are causing any change to the string itself because strings are immutable. And the only way to change this is to reassign in some way, reassign the variable that holds it, right? So if we assigned it a text to a new value, we could assign it to in consideration of its current value by concatenating it, or by maybe including it in an F string, or in multiplying it, or whatever. So there's a number of things we can do to modify the variable, but we can't. Nothing we do will modify the data type itself because strings are immutable. So casting to a string. So virtually everything, every other data type can be cast to a string. So if we have A equals 10, B equals 3.5, C equals a list of numbers, D equals true, E equals false. Let's see, true or false, F equals none. I want F to be false. Okay. Yes. Much better. Okay. All right. So if I just do, let's see if I know a fancy editor trick for this. Yay, I do. There we go. We'll just print each one, and then we'll print each one as a string. We haven't talked about tuples, dictionaries, or sets, but we can extrapolate from that. So if you look, this can be a little bit misleading. I want you to notice, right, when they print out to the my terminal, they look exactly the same, and that's because each printable type has a definition somewhere on how it's represented, and that representation is given as a string, right? So print has to have ultimately a string version of that thing to print out. So notice that in all cases it's the same, right? So there are times when this can be, misleading because maybe you have a problem that you're solving where you have an integer and you want to do something like maybe you want to do something with the digits themselves. You know, maybe you want to use like each digit as its own to like maybe enumerate some other thing in some other string or something. And then you want to later you have that same integer and you want to use that in some mathematical expression. So let's just look at this, and we can kind of, I'll show this with numbers, but we can we'll extrapolate similar behavior to the other types as well, right? So let's run this. I've got 10 and 10, 3.5 and 3.5. Well, the numbers I can do math with and say 10 over 2, and I can say 10 over 2, but we can't divide a string by a number. So if I did, you know, and in this case, it's really obvious in the code, but you know, maybe I do something like a equals string of a, and then I go back and use a again. Now a was an integer. I printed it out. It's an integer. We can do over 2. 10 over 2. No big deal there. Now I have a variable a that still prints to the same thing as a when it was 10. So my code looks the same. My output looks the same. It's just that the types are different. So it's something to watch out for. If you're getting a weird error and you're like, I am sure this should work. If you think, did I convert anything to a string? And the answer is yes, that you might be working with, you know, a valid idea, just you're working across an incompatible types. So something to watch out for, since Python will display them exactly the same. So yeah, I'll just leave that there. So we can cast everything built into Python. We can cast it as a string and it'll work. If you do that and you save it in a variable, I recommend that you name that variable something with str or st or txt in the variable name. That way it reminds you, yeah, this is not a number or a float. This is a string that represents the characters of a number or float. So that's one thing. So everything can be cast to a string. Sometimes that's useful, and also if you're not careful in casting back, if that's how you're thinking about your problem, then sometimes that can cause confusion. That can cause unforeseen issues. We can't necessarily cast a string to any other type, or in other words, we can't necessarily cast any string to any type, right? So let's think about casting a string to an int. What does that mean? So if I have a equals the string 10, and let's just print, or let's just say b equals the integer of a. Let's print b, and we'll, I don't know, let's print a. So this works. I can cast this string a as an integer. It's totally fine, but it's because I'm using digit characters and it knows how to do that. But if I put something in here, like what should hello as an integer be? Should I use the ASCII values? Should I, if I do, like I have all these characters, do I take the sum of that ASCII value? Do I do something where, multiple, like different strings could sum to the same number? So is it important that it be unique? Should I hash that number? Like there's there's so many. There are ways that this could be represented as an integer. I've had people say, well, why doesn't it just convert it to the ASCII value, or why doesn't it do this or that? And there's a lot of things that it could do, but none of those things are obvious in the way of being like there isn't an obvious behavior that it should take on, so it just doesn't work. And that's kind of the philosophy behind a lot of errors. Like, yes, there's something that you could do that could make this work, but is that really the behavior that you would want to expect? Since there's not an obvious answer, we'll just throw an error. So in this case, we can cast some strings to integers if it's a string of integer characters, right? So if I have, let's do 10, and we know that's going to work. If I put anything in there, or if I do 10 times 2, right, there's all these characters that it doesn't know what to do. So it has to be pretty literally, can't be like a string of an expression or something. It has to be pretty literally just the integer in order for it to work. I don't think I can cast, I can't cast a float string as an integer either. I can cast it as a float though. So 10.4, that'll work. I don't think I can do this. Oh, that will work. Yeah, so I guess I can cast to a float. So yeah, if your string is a string of a number, you can cast it to a number. If it's not, then you can't. And the lines on that are very strict. Even a space. Oh my gosh. Okay. Well, no, never mind. So a space does work. It will ignore a space, but any other character, it's not going to let you do it. Okay. Cool. Let's talk about. We've talked about casting things to Booleans. Booleans are another one of those types that are sort of universally castable. We can kind of cast anything to a Boolean. So if I have bool of hello and bool of empty string, I was going to make this a breakout, but I don't think it doesn't need to be a breakout. I think probably you all know this by now, right? Every data type in Python is either has either a truthy state or set of states and a falsy state or set of states. And for strings, they have one falsy state, which is empty string. So, and an infinity of truthy strings, which is the infinite set of every possible string of any length that is not empty. As long as it's not empty, it's truthy. Including if there's a space in it, just a space, right? Still truthy. Space is still something. Okay. Let's see. join a list to create a string. So I believe we've talked about, my gosh, did we talk about, I don't remember if we talked about slicing or joining. I'm going to talk about it again because it's important enough that if I did talk about it, it's not going to hurt anything to go over it again. So let's talk about lists and strings together. There's a or let's see. I'm having a minor brain fart. We did not talk about split and join because those are string methods. I was like, wait, those are list methods. No, I just had a momentary lapse of memory there. Okay, so I've just got a little bit of text here. It's not uncommon. You have a string, you want to like do something, you want to analyze the string, you want to analyze the words in the string. And by analyze, analyze is doing a lot of work there. I mean that just really broadly. You want to like iterate through each word. If I try to iterate through this for element in text, let's just see what I get. Print element. Let's see what I get. I get each character, each individual character, right? I could do something where I'm like word equals empty string, and then if L equals space, then I know it's a different word, and some point I'm going to be doing word plus gets L. I think I want to do this under the else this. Otherwise, we'll do word equals, we'll reset word, and probably want to do something with it before, so we can do list dot append word. Right, so we could do something like this, and then we could call it word list equals empty list. That's kind of a lot to do just to get a list of words. It's not terrible, but it's kind of convoluted, and it's so common to just want to go through each word. And this isn't that good. It's a little bit limited in some ways. So this is a common enough operation. It's worth just having a tool built in to just kind of generate a list of words rather than, so we can iterate through that or do something meaningful with each word and handle each word uniquely rather than each character uniquely, right? So just to prove kind of what's happening here, if I don't want to move on without running this so you can't see what's going on. This is going to give me that list of words. You can see I have these \n characters. You'll see a couple of these. So here and to are not separated because here and to aren't separated by a space. They're separated by a new line character. The new line character is this character. I'll do that, and you see I have a bunch more new lines now. So the new line character literally creates a new line, a line break. I guess I could do something like n and then have a list of, we'll do a tuple of things that I want to split the string on, right? But as we could maybe write our own function that could be a start of our own split function. Or if we could just use the built-in split function. Oops. Text. dot split. Okay, so I want to sort of frame something here. So most of the time that you want to convert if you have the thought like, oh, I need to convert this string to a list, usually you want it to be a list of sentences or paragraphs or words or something, right? There's some delimiter in the text that will tell you where you want that word to be split. So that's most of the times if you have the thought, I need to convert this string to a list, you probably want to use split so you can group substrings of the text into individual elements in the list. You might be tempted to say list text, but this is going to give us something totally different, right? This literally just makes a list where each element is its own individual character. There is a use case for this if you need to perform some mutable operation that exists for lists on a string. You can convert it to, you can cast the string as a list, capture it in a variable, perform your mutable operation on the list of single character strings, and then probably convert it back to a list, recast it as a list, and maybe capture that under the old variable name or a new variable name or something. So this can be useful, although honestly, I haven't had that come up. I remember, I don't know, a couple months ago, I did something where like I, in earnest, needed to cast a string to a list, and I thought, oh yeah, this is actually the best thing that I can do. I literally think that's come up once for me ever. So it's not, this is possible, but it just really isn't that common. So if you have the thought, I need to cast this string as a list, probably what you want to do is split, because you're probably after each sentence here. And I'm going to actually get this, and we'll kind of play around with this. This is why I have this text just in my notes document here. Let's have a few usefuls hanging around so I can play around with it. So if I want to iterate through the words, I can say for word. Of course, I get to call this whatever, but since it's a word, word describes it well. I'll say word in text dot split. Split. Let's print word. Okay. You can see I'm printing each word. We can print the whole list, text.split. So split returns that list of words. I can also optionally, if I don't pass an argument to split, as I'm showing here, it will split on all the white space characters. It will split on new lines, it'll split on spaces, and it'll split on tabs. Those are the three white space characters. This string has two kinds of white space character, which are new lines and spaces, obviously. If I pass it an argument, I have to pass it a string, and that will be the character to split on. Oops, okay, so there we go. So for sentence and text.split will give me each sentence. And if I split on periods, I'm going to get each sentence, right? Maybe I should call this statement, right? Because questions aren't being represented here, but split is limited in that way. I can only split on one character at a time. So if you want to split on multiples, you kind of have to engineer that and work it out yourself for whatever problem you're working on. But yeah, this will give me a list of each. Excuse me, a list of each sentence. I'll show this like this too. So we look at each element in this list contains a complete sentence or a substring that was delimited by a period specifically. There we go. Okay, let's do that. And while we're here, let's delete that. Just leave those in as examples. So that's split. So let me think of a good example. Let's say I have a list of strings. Well, that's convenient because here's a list of strings right here. Here's my list of strings. Let's call this sentences list is going to be this list of strings. And let's say I want to turn that back into a string. Well, I can't, same kind of thing here. I can't really, I could cast this as a string. I could cast this as a string, but here's the string. It just looks like the list, because remember when we cast something as a string, we get something that looks like it. It's not, this string literally contains the square brackets and the quotation marks and the commas and the spaces between the elements in the list. It literally contains all those characters. So what I want to do here is convert it to a string that I actually can use. So I'm going to use something called the join method. So split and join go together. If you have a string you want to turn into a list based on some delimiter, and you want a list of substrings, words, sentences, everything between, curly bracket or opening or closing curly bracket character, or everything between an L or I don't know, whatever you want. Then you can use split. If you want to undo that operation, or in other words, you could say, if you have a list of strings and you want to turn that into a string, you want to combine every element in that list into a string, you can use the join function, the join method. Now join is weird because we usually, and I want you to bake this in because this is kind of an exception to what we usually see. We usually see it's usually some string equals something, whatever. And when we call a method, it's almost always on a variable that holds an instance of the type that has that method. Join, we will most often see just called on a string literal like this. Since strings are not mutable types, all their methods return a value just like any old function, which is kind of nice. And they're nice and predictable. They just give us a value back, right? So this is string with space dot join sentence list, and whatever this string is going to be the delimiter that separates each item. Oops, I gotta save it here. So if I look at this, let's see what happened here. Let's kind of crawl through this. This is what that join gives me. And it kind of looks like my original text. Does anybody see there's one little difference between my original text and here, let me see if I can show this. There's one little difference, excuse me. There's one little difference between the original text and the output that I got. I'll try to screenshot this in a way to kind of demonstrate this a bit. Let me see. Just like that. Okay. And see if I can. Okay. We'll kind of A/B this and see if I can get a good shot here. Oops. And I'll just put this in Slack. You can kind of look at that. Okay. So you can kind of look at that now. So let's just see. So here's my original text. I did this split, and I just actually copied the result of splitting it. I could actually do this by saying, why don't I do it like this? It was this one. It was the result of this. So I don't need to put in that list literal there. I could do that, and that's going to be the same thing. And we're going to ignore these. These aren't doing anything for the process. So what I'm saying is I have that original text, and then I say sentence list equals text.split on periods, and then I join on spaces, and I get that output in my terminal. So does anybody see any difference in characters in one string over the other? Are the strings different at all, or are they exactly the same? I know I'm being very leading in my tone, but I'm sticking with it. Oops. Did I mess up? Did I post that in the right place? Oh, okay, my Slack is just not cut up. Weird. I had to reset Slack there a little bit. And we got a couple answers coming in. There's a few up there. Oh gosh, sorry about that. Cool, yeah. So the periods are missing, right? So I wanted you to kind of look through this and scour through it a little bit. One important thing you remember, when you split on a character, the list you get back does not contain the character you split on. So if I print this sentences list, oops, let me print this list of sentences. Right here, okay, here it is. You'll notice where the periods would be, the that element in the list just stops and then we have a new element. So you can kind of use this as a way, it's kind of a brute force way to remove things from a list, but okay. String slicing. Let's move on. Are there any questions on split and join? I know we spent a bit of time on these, but they're really useful. They're extremely useful methods. Things you use. I don't know if I would say you use them all the time, but like you use them enough and they make things easy. So. Okay. I'm not seeing anything. Feel free to put something in there if you've got it. So we talked about slicing and indexing. Real quick, let's do a quick poll. 1 to 3, how do you feel about slicing and indexing with lists? 1 is you really don't feel confident in understanding slicing and indexing. 2 is you feel like you get it, but you have some questions. Maybe you're a little shaky using it. 3 is you understand slicing and indexing, maybe not 100% fully, but you're like, yeah, I can use it. I get it. I can get by with it. And this is for lists, slicing and indexing for lists. I'm getting 2s, mostly 2s and 3s. We got a 3 in there. Okay, and another 3. Keep them coming. If you're a 1, I want to know about it. I know it might, like, I don't mean to put you on the spot, you know, but I do want to know if you're like, I don't want to leave you behind or nothing. Okay, going once, going twice. I'm getting almost all 2s and a couple 3s. Okay, it doesn't look like anybody's a 1, which is good. So if you understand slicing and indexing, if you have a handle on like, okay, I basically know what this is doing with lists, very similar for strings. So we think about lists as having an index starting at 0, counting up to the length of the list minus 1. Each index holds a specific element. With a list, that can be any type. With a string, that's just whatever character is at that location. So when we index or slice into a string, the indices refer to the location of a character, because obviously we can't have like groups of we can't have like an integer or other data types in a string. It's only holds string characters. Cool. I'm wondering, I think some examples are in order. I'm not thinking about like trying to get everybody from I want to be a little bit brief about this because I'm seeing a lot of 2s and I think that's good. I think that's fine where people are saying they're at. As many 2s as I saw, I think that's a really good sign. You know, your understanding of indexing, it's just a little bit of a dense topic, and I remember it kind of took me a while to get comfortable with it. So as many 2s as I'm seeing, I think that's actually a really good sign. So we're not gonna necessarily like ameliorate all of that right now, but I think it's worth it to give some examples at least. Okay, so text. So we've got our text here. So let's say I want to print out woods these are, right? Like let's say I just want to print out this substring. So let's just, I could count, but I'm just gonna kind of guess and see how close I get. Print text sub ::. Now, when we do our slice, I'll do an index first, or a simple subscript first. If I just say 7, it's going to give me a W. The letter at the 7th index is W. If I do a 0, I'm going to actually get a new line character, which doesn't display. So 1 is also a W. So let's see if 7 is actually the one that the beginning of where I want to be. I'll just slice it to the end, just see where it starts. Woods are these? Oh, I guessed the starting place correctly. And then let's say, I don't know, 15? I'm not sure. Woods these, woods, oh, is it woods these are? Yeah, it is. Yeah. Okay, woods these 20. Woods these 22. Woods these are. Okay, so that's how I can do a slice. Same thing, right? Does that clarify anything for anybody? Thumbs up, thumbs down if that feels a little clearer. You know, like I said, I don't think my goal right now isn't to get everybody from a 2 to a 3 right now, but does that clear anything up? Thumbs up if that helped you understand something, or if you already understood that. Thumbs down if you're confused or that didn't help at all. And don't be shy. I mean, I won't take it personally if you give a thumbs down. I won't be upset. Okay, thus far unanimous. People are good. All right. I'm gonna assume we're good on slicing and indexing. What I just did here, you know, like this is something I encourage you to do. You know, if you're curious about something, throw it in a print and just play around with it until things start to make sense. You know, if you don't remember if slicing involves like starting at a given word or how indices work in a list, just throw some numbers in there and see what happens. You know, or I mean, how they work in a string or a list or whatever. You know. Okay, cool. Membership. So similar thing to lists. Membership in lists, let's just say list equals 5, 4, 3, 2, 1. And we can say print 6 in list, print 2 in list. Yeah. Right, 6 is not in the list, so that's false. 2 is in the list, so that's true. Basically the same thing with strings. If I say hello world, text equals hello world, let's just do text. Obviously 2 is not in text and it can't be, so this gives us an error, right? Because 2 cannot be a member of text. So this says type error in string, you know, n as in checking for membership, in string requires left operand, not int. Excuse me, requires string is left operand, not int. I was like, what? Okay, so this has to be a string. So is O a member? Oops, I have to make it a string. Is O a member? Yes, it is. Is P a member? No, it's not. Is LO? Yes, it is. So with a string, like kind of the one big difference is I can check a substring like this. So I can check any contiguous set of characters in order. They have to be contiguous and in order, right? So ELOL, you know, is the same, you know, group of characters, but it's out of order, so that won't work. So I can check for a given character or any substring that might be a member of that string. Same idea as checking for membership with lists. Let's do a 1 to 3 on enumerate for lists. So how do you feel about enumerate? enumerating with lists. We talked about enumerate kind of briefly, but I think it was 2 classes ago that we talked about it. Just kind of skimming through. We're running short on time. I'm wondering what I want to cover. Sometimes 2 or 3. 3, okay, we got a couple of 3s. Applying count. We've got count, we've got f strings, case transforms. Covered split and join, replace. Okay. 1.5. 3. Okay, it's a little wider, a little more variance on this one. Okay, so I'll just juxtapose these two together. So enumerate the reason I want to cover enumerate is this is a tool that you really do use all the time. It's funny because you can just about any for loop you can write with range and len and make it work. But enumerate just makes a lot of looping just nicer. So what enumerate does, it allows us to kind of change our for loop, and it gives, rather than giving us one element back, it gives us 2 elements back. The first element it gives back is the index. The second element it gives back is the element. When I say first and second, I don't mean like per iteration. I mean each iteration it gives us 2 elements. First the index, then the element. So we'll just try this. Print IDX element. So anytime you're looping through something and you're like, oh, I also need the index of each element, I also need the index in this loop, enumerate should automatically pop to your mind. That is the answer to that. And that happens constantly. They're constantly, working with some collection, a string, a dictionary, items, generator, or range, or zip object, or list, or whatever you're iterating through. And you want obviously you want the elements in there, but you want the index of each element. So enumerate is really good for that. This is how it works for lists. This is how it works for strings. Same thing, just with the analogy of iterating through a string, iterates through each character one at a time. I hope that's clear too. I hope I made that clear. I know I've kind of given examples of that, but let's just explicitly state it. If I iterate directly through a string, I get the characters. Character, I'll do CH for character. Okay. That gives me the characters. So if I enumerate a string, oops, I get the characters and each index of each character. Cool. That's all we've got time for today. I think we made a lot of good headway. I'm going to pick up on replace and probably go over enumerate again next class, because like I said, enumerate comes up so much that I don't mind just reinforcing it, even if it's a little redundant. So we'll pick up from replace. We'll talk about replace and go on from there tomorrow. Let me wrap up the recording and we'll open up for questions.